Hello, everyone, and welcome to a live Ask Me Anything session. We are coming to you live from our really fancy video studio here on the MathWorks Lakeside campus here in Natick, Massachusetts. My name's Connell D'Souza, and I work on the student programs team. A big part of what I do every day, I come into work every day, is to try and help students, you, be successful with using MATLAB and Simulink. I'm joined today by my colleague, Eric. Eric, please introduce yourself.
Thanks, Connell. I'm Eric Hillsberg. I joined MathWorks about 2 years ago and am now in our marketing development group. So I help to communicate about our products, I help create videos, and I help to understand what our customers want from us in terms of what we create for our products. I graduated from the University of Michigan with a degree in aerospace engineering, so I'm trying to apply that as best I can.
I don't say go blue, I'm sorry. Anyway, what are we here to talk about today? Essentially, we're hoping to spend the next hour answering your questions, showing you some of our favorite MATLAB tips and tricks, and so on and so forth. So if you guys can pop your questions into the chat on, I guess, the side or that side. Anyway, pop your questions in the chat. We'll try and answer as many as we can. Eric, why don't we take a look at the chat and see if there are any questions coming in right now?
Yeah, so it looks like we've got a couple questions already. The first one is how to solve an implicit equation in Simulink.
Ooh, hang on to that. We're gonna open up Simulink in a little bit, and then we'll show you how to solve implicit equations.
Absolutely. Yeah, there's another one in here. Someone is asking about what we can do with artificial neural network controllers.
Excellent. Also, Eric, do you want to take that?
Sure, yeah. So it depends a little bit about what you mean. We can do things like reinforcement learning, where we can teach an agent, like a neural network, to take controller actions. Or we can do something like using a neural network to have a reduced order model of our system and use that in something like a model predictive controller. So it depends a little bit about what you mean and what you want to do, what the best approach would be.
Yeah, so I mean, everything that Eric mentioned, whether we talk about reinforcement learning or fuzzy logic or whatever other types of controllers, the MATLAB documentation is an excellent place to start. You know, we've got toolboxes for a number of things. For most of you students out there, if you're at a university, you might have what's called a campus-wide license. So let's go and check what's the best way to figure out if you have a campus-wide license. If you go onto this link that you can see on the screen, so it's mathworks.com/products/MATLAB-campus, you can essentially go here and click the Get Started button. And what this will do is, if you have a MathWorks account created with your school email ID, it'll redirect you to what we call the MATLAB homepage in MATLAB Online. So what the MATLAB homepage is essentially the first time you get into MATLAB Online, this is where it takes you. What you can see here is you've got on the left-hand side, you've got links to the documentation, MATLAB Answers, which is when Eric and I are not here answering your questions, you can go and ask our community of millions of MATLAB users who interact and answer questions on the MATLAB Answers page. We've also got something called File Exchange. File Exchange is our file sharing network. The good thing about File Exchange is now File Exchange connects to GitHub, so you can cross-post your GitHub repositories to File Exchange, and we can go and take a tour of that in a little bit. But as Eric mentioned, the documentation is usually a good place to start looking for what you're looking for. Every function in MATLAB is documented with examples, and I think that's one of the things that kind of sets MATLAB apart from some of the other tools out there. Is you never need to struggle to figure out what a particular function or a particular term in that function means. They also have a number of examples. So if you can click on this examples tab, and again, the documentation is kind of indexed by application areas as well as product areas, right? So say we spoke about control systems. We can go into the control systems examples, and as you see, we've got a variety of products as well as examples that go with each of the products. So Yeah. Hopefully that's good to get you all started. I see that we're getting a few more questions in the chat, so let's try and answer some more.
Yeah, absolutely. Looks like we have a very specific question, so I'm wondering maybe
Okay, yeah.
if you know the answer. Can we solve the Collatz conjecture with MATLAB?
I do not know what the Collatz conjecture is.
Maybe that's a good question to put onto MATLAB answers.
Yeah, we'll let's pause on that for a little bit. We'll try and do some Google searching, and try and get you an answer to that.
So yeah, the next question is it possible to use real-time Simulink to actually control a plant or process? And is it always attached to SpeedGoat products?
Ooh, that's a very interesting question. Yeah, so Simulink real-time and SpeedGoat are essentially real-time simulation devices, production devices, right? So SpeedGoat at its base is SpeedGoat builds the real-time hardware, and Simulink real-time is essentially used to program that. A little bit later on, Eric's going to show you how to program an Arduino. You could follow a very similar process with Simulink real-time and the SpeedGoat. Typically, what you do in a real-time simulation environment is you want to, in the realm of simulation, there's no concept of real-time, right? A computer will run a simulation as quickly as you want it to. Now, there are controls in Simulink that can help you what we call pace a simulation. But again, unless you're working on a real-time hardware system, it's kind of hard to actually, even though Simulink will tell you, hey, we're running the simulation in real time, it is constrained by the hardware. So when you use a product like SpeedGoat, like one of SpeedGoat's machines, you're able to have a hard time constraint in terms of making sure that the simulation's actually running in real time. And typically, an application of this is used for simulating various kinds of scenarios. Like let's say you're trying to simulate your electric vehicle. I'm just making stuff up. But if you were trying to simulate your electric vehicle and you want to have it go through a particular drive cycle, by putting your plant and your controller on a set of SpeedGoat hardware, you can ensure that your code and your controller is reacting in real time to the data that's coming into, or able to make decisions in real time.
Right, and I know we do have some examples of this within our documentation. So
we do. I can pull it up.
All right. While he's doing that, looks like we have some other questions coming in. Vanch, I'm not sure I understand your question, so maybe you could rephrase it and we'll come back to it. We have another question about the artificial controller, asking what would be better, using a fuzzy logic controller, an artificial neural network controller, or a hybrid. And the answer to that is always going to depend on your application. So it's very difficult to answer that without understanding a little bit more about what you're trying to do. All right, and we have another question in the chat. For understanding MATLAB, do we need to know Python? What do we need to know to be able to understand MATLAB?
Well, MATLAB and Python, I mean, at the end of the day, they're both programming, languages, right? So a lot of, it's kind of like if you learn one, you kind of, obviously the syntax is different in different languages, but in terms of concepts, it's the same. I think the best way for you to start learning MATLAB, and I can pull that up for you real quick over here, is again, as I said, if you have a campus-wide license, and if you're at a school that has a campus-wide license, you have access to self-paced online courses, right? If you don't have a campus-wide license, you can still take a look at the MATLAB on-ramp, which is a free 2-hour course that assumes you know nothing in MATLAB, right? So it assumes that you're an absolute beginner. It teaches you some of the semantics of the language, what the syntax looks like, what the MATLAB IDE editor, command window, all that looks like, what they do. Similarly, for the Simulink on-ramp, again, assumes you have absolutely no knowledge of what Simulink does, what Simulink can do, and it'll kind of build up your knowledge with a combination of videos plus code-along kind of exercises that you can take. The other things that you can look at is you can also look at Simulink fundamentals. Simulink fundamentals and MATLAB fundamentals are both longer form courses, so they are, they're typically longer, take you into a little bit more detail with the product and so on and so forth.
Right. So we have some more questions. Another question is, when we're trying to do sensor fusion, for example, using an extended common filter, how can we determine a drone's position by using optical flow sensor data and barometer sensor data? So I'm not sure if we have any documentation examples that go over exactly this use case, but we do have some documentation examples that go over using the barometer sensor data within an extended common filter, as well as I think some optical sensors, maybe not necessarily together. Perhaps looking through our documentation might help you find exactly what you're looking for there.
Actually, if you're interested in something like that, again, I'm not sure on the specifics, but I know that we support the Parrot Mambo mini drone. And the Parrot Mambo actually uses a combination of a barometer and an optical flow sensor to measure measure movement, right? So the optical flow sensor is what's measuring its motion in the XY plane, if you will. We have I'm gonna try and pull that up real quick because I know that we have a support package for this. So I can talk a little bit about support packages now, which is it's on File Exchange. If you I'm trying to find the search bar. There it is. If you look for the Parrot Mambo support package, you can download this within your MATLAB or Sumilink product. You can't use the MATLAB Online version for this because MATLAB Online does not support a lot of hardware at this point. I mean, I know that it'll change in the future, but download this onto your MATLAB desktop, and then you will get access to a model which has it has the physics of the drone, but it's also got the sensor fusion element of it, where it's taking in that optical flow sensor data and the altitude sensor, right, which is in most cases a barometer.
Awesome.
Yeah, I think we should, I love that we've got so many questions coming in, but why don't you let's take a pause on the questions for a couple minutes, and let's actually open up MATLAB and see what MATLAB looks like and so on and so forth. So
absolutely.
Again, coming back to the MATLAB home that I was showing you all earlier, if you click on the Open MATLAB Online button, it'll take you to MATLAB in a browser, and also we've got dark mode, so we've heard your requests. But when you open up MATLAB, essentially what you have on the top is you have the tool strip. On the left-hand side, you have your file directory followed by the workspace, and then you've got the command window. Eric, if I had to ask you something, what is your favorite MATLAB feature?
Ooh,
Pick one.
Favorite?
I already know what mine is, and please don't copy mine.
Well, I think my favorite overall MATLAB feature is the ability to have all of your files organized nicely into a project for you, where you can create shortcuts and run your models all with the click of a button.
Yeah, and so what Eric's talking about is MATLAB projects. Very cool when you're working with a group of people. You have 20 code files. They can, you need to, the moment you open it up, you have to run a particular order of run the scripts in a particular order to get your environment set up and all that. MATLAB projects is excellent for that. It's also a nice way to share, because when you're sharing a project, it essentially makes sure that it's got all the files that you need, right? So if you're sharing it with your project partner or something like that, it's a lot easier to do that. We've also got Git version control associated with projects, so you can save your project online and make sure your code is version controlled, which is the one thing that drives me up the wall is when people save code as code_final, and then the next person is like, no, wait, I want to make it code_final, and then there's final, and then just use Git. It's a lot easier. It's a lot cleaner.
Saves a lot of time.
Saves a lot of trouble more than anything else. Anyway, so speaking of favorite features in MATLAB, mine has to be the live editor and the live task that we've come out with in the
That's a good one.
in the last few years. So I'll show you what a live script is. So a MATLAB live script is essentially it's a rich text environment, right? You've got you can have think of it like a sheet where you can have code, documentation, pictures, videos, GIFs, all within one sheet, so to say. A lot of our examples from the documentation are now in live scripts. So when I go ahead and open up a documentation, you'll see what I mean. But as you can see, I can go to the insert tab and add things like control options. So this would be things like checkboxes, date pickers, file browser, etc., etc. I can also have text or a table of contents and code, right? So you can insert code both as MATLAB code and as plain code. You can also have other text features like tables, images, hyperlinks, as well as equations, right? You can actually have formatted equations in there. So if you're trying to publish your code on GitHub or publish your code on File Exchange, you can document your code well and share it with your peers. It's also nice because you can, this could be your homework assignment. You don't have to. I remember when I was in grad school and we didn't have the live scripts around at the time. I had to write everything in Word and then write all my code in MATLAB and then copy paste the code into Word and copy paste the plots, and I could have saved half my time if I didn't have to do that.
I spent a lot of time writing LaTeX.
Yeah, there you go. Okay, so another new feature that we've added recently to the MATLAB live scripts is MATLAB live tasks, right? So essentially, what a live task is if you've got a piece of code that's repetitive, things like importing data, creating plots, cleaning missing data, etc. We've essentially packaged that for you as a task. So the one that I'm going to show you today is the solve ODE task. So when we pull this up, and let me just adjust my view here so you can see more of it.
Yeah, this is a really awesome live task. I wish we had this when I was still in school.
Yeah. It's essentially what you can do with the help of this live task is you can essentially define an ODE and then have MATLAB kind of solve it for you, right? You don't have to worry about writing the code for all of it. So you can choose your ODE type, something like this, or either a system, some kind of system of equations, or if you've got a single ODE. There are some options that you can play around with. We can talk about advanced problem details, solver options, so on and so forth, and then display results. But like everything with MATLAB, every time you with these tasks, there is code running under the hood, right? The good thing is the live task actually exposes the code for you, so you can copy the code, paste it somewhere else. So. So what I'm going to do is I'm going to show you how this live task works. I'm going to pull up an example. In the meantime, let's take a look at some of the questions that we're getting. So so we can keep answering some of your questions.
Absolutely. So the next question in the chat is asking about writing transfer functions in Simulink and then generating PID code for the Arduino. So actually, a little bit later on, I'm going to show you how to do that. We're not going to be generating PID code for the Arduino, but I'm going to show you how you can deploy a very simple example that we have onto the Arduino to control a servo. All right. Another question is, can we make digital twins of machines using MATLAB, and what is the process?
Interesting. Digital twins. So essentially, when you talk about digital twins, it's a mathematical representation of your system, right? So you can essentially have a digital twin of anything. You can have a digital twin of that servo that you've got sitting there, or you can have a digital twin of a massive power plant or an electric vehicle or a drone or whatever. But essentially, what a digital twin does is it's taking the physics of that system, right, and representing it in a mathematical form, virtually, right? And some of the advantages of that is, like for example, self-driving cars are really popular right now, right? And in order to tune the self-driving algorithms, you need a lot of data, right? So your options are either drive a car around the road and collect a bunch of data. That takes time, right? Or you can essentially create a mathematical version of that, load it up onto the cloud, onto some supercomputer somewhere and have it essentially speed up how, have it drive through a scenario that you've probably made in something like Roadrunner, and essentially collect virtual data of the same. So you've got, you've got the ability to collect way more data in a shorter period of time. So that's one of the examples of a digital twin. I'm sure you can make a digital twin in MATLAB. My recommendation would be to use Simulink for that, because the big thing with digital twins is you have to have that notion of time. You have to, when you're running a simulation, you have to be able to step through a simulation and essentially move forward in time. With MATLAB, a lot of that you'd have to write that yourself, but Simulink is built for that. Like Similink's got, it helps you say, okay, hey, here is my function. Run it for 1,000 seconds, or 10 years, or whatever number you come up with, and Simulink is able to do that for you without having to make you kind of figure out what the time step is, figure out what the if you need a shorter time step or a longer time. Like Simulink solvers are able to do that for you. So my recommendation for digital twins would be to pick that Simulink and model-based design workflow for it.
Right, and if you are working with a system that may be really complicated, but you know what makes up that system, you can use something like Simscape, where it's even easier. You can select the components that are within it. As long as you know some general parameters of what those are, you can model your system a lot easier than writing out all of the complicated equations. We'll get into that a little bit later too.
Right, and the other thing about Simscape, you can also import CAD in Simscape. So if you have, again, the caveat is you have to have a good CAD model, right? Your CAD model's got to be, it's got to be a well-made CAD model in the sense that the mates have to be good, and because again, we've got something called the Sim Mechanics link, which is a product within Sim Mechanics that'll essentially take your CAD, convert it into a Simscape version of the CAD, and then you can use that to build your digital twin.
I believe that's a new product now. It's Simscape Multibody.
There we go. Simscape Multibody.
Yes. So make sure you're looking for the right thing. We change the name sometimes.
All right. Okay. Cool. So again, I was talking about the ODE live task, right? If you've been using MATLAB for a while, you would have noticed that, and you were using the MATLAB desktop. The documentation was always on your desktop. We've actually moved to having only online documentation now. So that's a new change that's happened recently. But if you go to the documentation link, you can either click the copy command button, which if you're using, you can just go and type this in the command window. But since I'm using MATLAB Online, I'm just going to click the Open in MATLAB Online button, and it's going to tell me that. So as soon as I pull this up, I'll see that that example will open up. Right here. It's telling me it's busy, but it's cool. Let's take another question while we're
it has to communicate with the server, so sometimes that can take some time.
Yeah.
Someone's asking if it's possible we can simulate Brian Douglas and get more Tech Talk videos.
I'm gonna have to send him a Teams message after this, because
yeah, I'll let him know that you're asking for more. He is very happy to make more videos, but he's a very busy man. So.
Excellent. All right, so let's look at this. Let's look at the simple. That wasn't what I was trying to. I wanted to open up a little more complicated example. So not the single ODE, but let's do this one instead, which is. I don't know why it's doing that. Oh, there we go. Solve a system of first-order differential algebraic equations, right? So again, what you can see here is sorry, I hate to make that happen, but what you can see is a simple system of equations. Everyone's kind of seen an equation like this in some some math class that you do in college at least. The first step in an equation like this is to obviously write it in that. Essentially take all the derivatives to one side and represent that, because it's a system of equations. We can represent that as a matrix. Pretty simple. Nothing. We haven't done anything crazy yet. The first thing that you have to do when you're using this solve ODE live task is you have to essentially create a function of the ODE, right? So you create a function and then you pass that function handle to the live task. So all that we're doing here is we're essentially taking this right hand side matrix and representing it as MATLAB code. And then we're also creating a new variable called mass matrix, which is essentially this mass matrix on the left hand side, right? So now obviously this is a differential equation with respect to time, so there's got to be some initial conditions and boundaries, right? What are you trying to solve this over? So our initial conditions essentially saying at time equals 0, y1 is 1, y2 is 1, and y3 is -2, right? These are just simple initial conditions. You can chain them around. There's nothing, depending on what solution you're looking for. We're also going to set a time interval to say we're going to run it for 10 seconds and see what it looks like. So I'm going to hide the code for now, just because, as you can see, all of this this code is a little, there's a significant amount of code to write, but why write code when you can point and click at things, right? I don't know what this error is, but let's, oh, there we go. I didn't open for a second. But anyway, so when we get back to the solve ODE, let me try and enlarge this. All
right, while you're doing that, why don't we go to the chat and see if we have any other questions. So someone's asking, what are the common factors in choosing between MATLAB and Python, especially for control topics? So I think that's going to depend a lot on what your application is, but if you have access to a MATLAB license, running your simulations and running your MATLAB code is always going to be faster than running something in Python. Python is an interpreted language in the same way as MATLAB is, but it doesn't have the back end that we do to be able to run your code faster. So if you're running really large simulations, you're probably going to want to do that within our products. Another big factor is if you're trying to deploy that code afterwards. The code generation tools that we offer are really, really helpful in making that process easier, so you don't have to hand code yourself.
Yeah, I think the you kind of spoke about code gen and all of that fun stuff. But I think the one of the differences between MATLAB and Python is we've got specialized libraries that are actually developed by engineers, by domain experts, and they're well documented, right? So you can essentially you pull up an example. You can run through that. We spoke a little bit about Sumilink's simulation capabilities. If you're trying to write a simulation in Python, there's a lot of heavy lifting and kind of what we call housekeeping work in terms of ensuring that things like the timing aspect of it is working and stuff like that. So you have to do a lot of that yourself, right? Whereas Sumilink's got these solvers that are able to do all of that for you. And then of course you have the code generation piece of it. So for those of you that are not familiar, code generation is essentially, as we've spoken, MATLAB and Sumilink are both high-level languages. It sort of enables you to write code almost in English or write code in the form of blocks in Sumilink. But when you want to run that code on, say, a tiny little robot that's got a small little battery with like a Raspberry Pi running on it or something like that, you cannot and you should not be running MATLAB in that instance. You want to get to the code that's native for whatever hardware board you're using, and that's what code generation is. So we have a couple products called Similink Coder, MATLAB Coder, and Embedded Coder, and what these three do is that they help you essentially convert your MATLAB or Similink models into low-level C, C++. If you are interested in CUDA, we've got something called GPU Coder, which will convert your MATLAB or Similink code into CUDA code that is native to the NVIDIA NVIDIA GPUs. Similarly for PLC, for things like the Xilinx, you've got what is it called?
HDL coding?
HDL. There we go. That's the one. For boards like the Xilinx, you have HDL code. Again, we can convert MATLAB and Simulink into HDL code. So there are a lot of benefits to using the MATLAB or Simulink environment over something like Python, especially for controls, because you're typically not developing controls in isolation. You're doing it in it's tied to some simulation environment, which there are other aspects of it which make MATLAB and Simulink a little more attractive. Okay, I think I've got this running. So I'm going to show you how this live task works real quick. But essentially, we've picked the ODE type. We've said m dy dt as a function of time and y. We gave it the local function, so that was that function that we had created up above. We've also got the mass matrix, and we're giving our initial conditions as a vector. So you remember we said y1 equals 1, y2 equals 1, and y3 equals minus 2. We're also going to give it an initial time, so we're starting at t equals 0, and we want to run this for 10 seconds. So I say start in n times, not 0 and 1, but 0 and 10. There are some solver options. Again, you probably heard me say solver. If you've done a math class and you've used MATLAB, and you've probably heard of ODE 45. ODE 45 is one of the solvers. ODE 15S is another solver. You can go look up the documentation on what all that means. We could spend hours talking about it, but essentially these are numerical solvers. So it's Simlink's or MATLAB is just going to be able to solve that differential equation for you numerically. So I'm asking MATLAB to pick the solver for me. I don't really care which one it uses. I give them some tolerances to make sure the solution's converging, and if I go and hit run on this, it's going to hopefully solve that equation for me, unless it gives me an error, which I think it did. Oh, it said doesn't know what well, that's because I didn't run section 1. So let me go ahead and actually make sure that it knows what mass matrix is. And now if I go ahead and click this, we should be able to see that we've now got the solution over time, right? So super simple. I remember having solved so many equations in school, and I had to do them all by hand. But with something like this, you just kind of plug and point and click, and you're good to go. And as you see, all of the code that's running in the live task is visible here for you to copy and share if you need it. But if not, that's all right. Cool. So that's a little bit about MATLAB for you. I think we should probably spend some time answering some more questions, but also firing up Simulink. And I know, Eric, you've got some fun Simulink stuff to talk about. So
yeah,
we're gonna let our video team do some magic and switch our screens around. And in the meantime, I'll start taking some questions. So let me pull up the chat real quick.
All right.
Okay, so Vikas is asking us, saying that he has to build a drone using Simulink and port the code over to an STM32. Yes, we have support for a number of hardware vendors. STM32, I believe. I'm not sure the specific, the F407, but I know that we support the STM32 family of processors. So, Vikas, I think the place where you should get started is perhaps go and take a look at one of the drone demos in either the UAV toolbox or the aerospace toolbox. So that'll give you an idea of the of the actual, the physics of the drone as well as the controllers that are being built. And then you can essentially look at the STM32 support package, which will have the drivers for you to deploy that code onto the STM32.
All right, so let's get started looking at Simulink. So Simulink is a differential equation solver at its heart. So if you have your equations already written out, like I have right here, in this case, we're modeling a mass spring damper, which is a very common plant model that a lot of you will probably be familiar with from your time in school. All you really need to do is figure out which signals are going to represent which parts of this equation. So if we're taking a look at this line right here, we know that the force that is applied to the mass is going to be a function of a stiffness coefficient times the position away from its neutral location, as well as a damping coefficient multiplied by the velocity. And we can see that here in our equations in Simulink. So if we're starting with our position, we can see that this position comes down and is multiplied by this gain, which is our stiffness coefficient, and goes into this summation. In this case, it's a subtraction block before it is fed into the rest of the equation. And we can see also that right before this, we have an integration block. And what this does is it integrates over time the signal that's fed into it. And we know that the position is the integral of the velocity. So what we're feeding into this is the velocity. If we follow the velocity term, we can see that's being multiplied by our damping coefficient. And both of these two terms are then fed into this gain that is multiplying 1 over the mass. So if we're looking at F equals ma, to be able to get our force calculations or our accelerations, we need to be able to divide by the mass. So that gives us our acceleration, and we integrate that to find our velocity.
This is kind of like a Lego, like a little Lego kit for differential equations, if you will.
Right. Yeah, it's great because as long as you know what equations you want to model, you can build them out really nicely. And one of the great features here is if you're trying to find a specific block, you can double click on the background here and type in and find whatever you wanted to do. So if I wanted to create some kind of model predictive controller, oh, I guess the block is just called NPC. There we go. NPC controller. I can just search for it nicely and it'll come right up. So as we were talking about earlier, we also have, oh, and here's the parameters that you can mess with to be able to decide what you want to put into your NPC controller. All right, so as we were saying earlier, you can model things not just in Simulink, but if you actually know what that system is made of, you can model it in Simscape. So what we have here is a mass spring damper system modeled in Simscape.
So what is the difference between Simscape and Simulink, like in terms of, how would you correlate that to the real world?
Right. So with Simscape, we provide components that are correlated to the real world. So in this case, we have a spring and a damper, and you give the coefficients, like the damping coefficient and the spring stiffness, and you put those into there. And you can also deal with things like nonlinearities. We've stayed away from that for this case, just to keep it a little simpler. But you can model these just by putting them together. In this case, we're using the Simscape mechanical library. And so we have our mass, and we have our spring, and we have our damper right here. And right here on this top part, the VSC, that's just a way for us to measure. So this would be some kind of sensor in the real world. But this is just going to be measuring the displacement of the mass over time. And what we can see is we can run these two models side by side and see if they're representative of what we expect it to look like in the real world. And we can see that both the Simscape and the Simulink model are matching very nicely to what we would expect them to do. The velocity over time is going to 0. And they seem to be perfectly overlapping, which is great. That means that our simulation is doing what we expect it to, and that we can represent it in multiple different ways, which is really helpful for verifying that our simulations are correct.
Right.
Yeah.
What is a use case when you'd use, say, Simscape over Simulink?
Right. So if you have a really complicated system like a spacecraft, and you don't know how that spacecraft is going to behave, but you know what the components are made out of, you can start building out your Simscape model to be able to create a
Right.
representative model of what that is without needing to know all the underlying equations. We call this physical modeling because you're putting together pieces and
Physical
representing
pieces,
it
right.
with physical equations under the hood, rather than having to figure out what all of the mathematical representations are, which can be a pain.
Yeah.
Do we have any other questions we'd like to?
We do have some questions. So Goosebumps TV is asking us, I would like to master image processing and image registration in MATLAB. Any tips for a complete beginner? We were talking about on-ramps earlier. I'm just going to go and look for that real quick, but I believe there is something on that for you. So we've got a computer vision on-ramp, which I'm going to have our my lovely friends on our video team send that over to you in the chat. But we've got a computer vision on-ramp, which kind of, again, assumes that you know nothing. I guess it assumes you know how to use MATLAB at this point, but you're kind of a beginner to computer vision. We don't have one for image processing, but I believe that I can look this up real quick. I believe we have a more longer form course. So if you're at a school that has a campus-wide license, you can access that from there.
Right. I think actually on our YouTube channel we had a video go out today about this topic, so definitely check that out. And look through our documentation. There's a bunch of examples in there about image processing and computer vision.
There's a number of videos on the topics. It's just that you're going to have to kind of find your way through MATLAB's videos. But I'm sure if you type those topics into MATLAB into mathworks.com, you'll be able to find that real quick. Yeah.
All right.
Let me look up another question while I get those links out to you. So it says, I'm a student from Vietnam. Wow, that's a long way away. Hello.
Wow. Hey.
nice to have you on the chat. I would like to ask how to connect a PLC with MATLAB in real time. Do you want to take that? Essentially, for PLCs, we have similar support packages. Again, I can look up some links. But actually, that could be a good way to segue into the Arduino. So essentially, the process is very similar with what Eric's going to show you on the Arduino side of things. But you obviously need the specific libraries that you need for PLC.
Right. Awesome. So yeah, right before we get into the Arduino, I want to show you and motivate you maybe why you would want to put this onto a microcontroller like an Arduino. So looking at, this is a mass spring damper system right here, similar to the exact same one I just showed you. In this case, we also have a force source. So this is allowing us to manipulate the mass with some kind of force. And we're going to control this system by using a PID controller. So if you've taken a controls class, you've probably been accustomed to PID, and we offer some great ways to auto-tune those controllers. So in this case, I've already done that so we can save some time. But if we wanted to, we could take a look and see that we have a proportional, integral, and derivative gain. So we've already got this gain, all of these gains scheduled, and using our motion sensor, which is out and apparent this time rather than hidden, we can run our simulation and see that we're controlling the mass to these specific commands relatively well. It takes about a second to settle down at their new position. So in this case, if we wanted to deploy this out into the real world, we may want to put this onto something like an Arduino. So I've got an Arduino here right now, and I'm going to show you how you can deploy code onto it to control a servo here. We're going to keep it a little simple and not do the PID, but just to demonstrate what we can do with this. So I'm going to switch over to this really simple model, which you can find in our examples. All you have to do is select which hardware board you want to target to. In this case, I've got an Arduino Uno right here. And I'm telling the Arduino that my signal is going into the pin 4 location. So I've got the hardware connected here directly into pin 4 to be able to control this. And as we spoke about earlier with code generation, I'm just going to be deploying code with the click of a button here. So we're going to be changing the shaft angle of the servo in a ramp back and forth. And all I have to do is click build and deploy. So I'm going to wait for that to deploy here. And while it's doing that, get ready for you guys to be able to see. This takes some time because we're trying to generate C code here from our Simulink model.
Yeah, so essentially what's happening under the hood is it's going to convert that, and
there it goes.
So,
So yeah, you can see the servo is moving back and forth just as we expected it to. And one of the great things also with code generation here is that we can take a look at all of the artifacts that were generated. So we can take a look at some of the C files that were created, and we can go in and analyze which parts of this are mapped to which parts of our model, especially as our code generation gets more complicated. Right. This can be really helpful in debugging and figuring out what's going on.
Right. Our recommendation, though, in a case like this is, if you want to make a change to the code, avoid changing the low-level code. You want to go back and make the changes in the high-level model, right?
Right.
But that being said, that code that you saw, the C code that you saw, is editable. It's like you can copy it, take it to another IDE, say Visual Studio or something like that, and integrate it with some other code base that you've got. But our recommendation is, as far as possible, you always try and avoid editing the low-level code because there's no backward traceability, right? So, like, you want to make the change in your high-level model and then regenerate the code. As you said, it took less than a couple minutes to get it done.
Right. All right, so that's a big overview of Simulink, and I guess just to highlight some of the key things that I covered, we can model our systems. So in this case, we modeled a mass spring damper, and we can take that model and create a controller for it very easily with auto-tuning in PID, and then we can use our code generation tools to deploy that directly onto a microcontroller. And this workflow is what our customers are doing out in industry as well as for student teams. So this is a really, really key benefit of being able to use Simulink and model-based design.
Yeah.
All right, I think
awesome.
We have a couple more questions.
We've got a lot of questions.
All right.
So, all right. So Kim asked this question: for drone positioning, I only see the example file where they use GPS plus IMU sensor data to determine the drone's position, and they use filter equals INS filter mark. Kim, that's a little too specific for us to be able to probably answer that here, but I do recommend using, maybe going to MATLAB answers and posting your question there. As you said, there are a number, millions of MATLAB Simulink users around the world. I'm sure someone will be able to look at this more specifically and answer that question for you. Mohammed asks, I'm a mechanical engineering student. I'm interested in learning the aerospace block set, the aerospace toolbox, the UAV toolbox, and the LiDAR toolbox. But I cannot find an on-ramp. Yes, we are actively in the process of making more on-ramps. So, I'd say keep checking back with the on-ramp page, and I know our training services team is working with full gusto towards getting as many of these courses out for you. Another thing that I know for sure is that there are some people on my team that are putting together a video series on using deep learning with LiDAR. So if you're interested in that, I'd say follow the MATLAB students, so MATLAB_students on Instagram. We'll definitely post on it once it's out, but that's in the works, and we should have something ready for you soon. Also, another way to actually learn these toolboxes is just go and explore the documentation, as well as look up some of the videos that we've got on mathworks.com. Or YouTube. There's a number of videos on these topics that'll help you get started. Yeah, go ahead.
Yeah, absolutely. And I know personally the aerospace team is definitely working on trying to figure out if we can get an on-ramp for you guys, because I know that's something that has been requested.
Okay. We have a question on, so someone called me a professor. I never thought I'd ever hear that in my life.
Professor Connell.
I'm reaching out to seek guidance on beginning my journey with Simulink for power electronics. I have a good on-ramp for you, so I'm gonna pop that to you in the chat. But we do have a power, I believe
I think it's power electronics.
Yeah.
So within Simscape, we actually have a few different domains. One of those is electrical, and we have an on-ramp that specifically talks about this. So I think Conwell's going to get you a link to that in the chat.
Yeah.
But yeah, definitely go check this out. I've personally used this on-ramp, and it was very helpful in helping to understand how you can do these kinds of workflows.
So we've got a power electronic simulation on-ramp, which I'm going to have my friends in the video team pop a link out to you. And we've also got a power systems on-ramp. So both of those are things that you can get started with. Obviously, again, assumes that you're definitely a beginner in that, and then once you get through that, there's a number of videos on mathworks.com that you can go and deepen your knowledge with that. I highly recommend that before you get into this, you probably take a look at the Simscape on-ramp as well as the Simscape battery on-ramp, because Simscape is a little different from Similink in the sense that it's almost like the sort of signal lines that you see between Simscape and Similink are different. And so if you're a Similink user, it takes a little bit of understanding to figure out how those connections work and what is the difference between a physical connection and a signal. So I'd say take a look at the Simscape on-ramp as well. But definitely power electronics and power systems are two things that you can look at.
Yeah, absolutely. And just not to harp on this too much, but the on-ramps are a great tool. As I was on-ramping within the company, I used those to really beef up my knowledge of our products, and they were awesome.
Yeah. Someone says finishing courses on the Similink on-ramp would be helpful. Yes. But actually finish them, don't start.
Right.
But yes. I think the on-ramps are amazing. I'm so happy that I don't have to go and teach people introductory stuff anymore, because we've just got like these very, very highly well edited and well produced on-ramps, which are I know professors. We work with a lot of professors. They hand that out as assignment 0 in their classes now. Because it's like it's really amazing. These on-ramps are really good. Okay, I'm trying to look if we have any more questions. But I think in the meantime, what I'm also going to do is I'm going to I know we've spoken a lot about learning resources, but I want to show you a couple of other cool things that maybe might get you interested in using more MATLAB and Similink. So we're going to go ahead and switch our screens. There's going to be some real magic happening.
Yeah, behind the scenes, they do a lot of great work for us.
But as soon as my computer decides to come back on, coming back to the MATLAB homepage. I know we spoke about MATLAB answers, so let's click in and see what you can find here. You can essentially find that you've got a number of ways that you can ask questions. You can see some trending, some newest activities, so on and so forth. There are a lot of math workers that actually sit and answer questions. A lot of developers, a lot of field experts, a lot of subject matter experts, etc. So as well as people that have been using MATLAB for years. So typically, if you want to find an answer, search here or post your question here, and someone will get to it. The other aspect of the MATLAB community or the MathWorks community that we spoke about is the file exchange. So file exchange is where you can find little code snippets, little functions that people have made.
And even math workers have made. I've personally put out code into the file exchange.
Yeah,
so.
And again, we've spoken about the millions of MATLAB users. Anything that you're trying to do has been done before. Like for the most part, you'll find code here. So you can use this to either publish your code or find code for things that you're doing. I always, whenever I'm writing new code, I always come here right away. This other new feature that we've added recently has been called the AI Chat Playground. again, so it's kind of like it's kind of like a GPT model that helps you answer questions. It's like your chat assistant. There is a caveat that obviously it is AI generated, and generated code and text may be inaccurate. So you want to use that with a grain of salt. But for example, I can type in a plot. I've got some suggestions here. Some suggestions here, but let's see what one of these are. So it says create and plot a sphere, and this AI chatbot is going to give me the code for it. So I can go ahead and I can just actually run it here, and it'll tell me that it's executing. And yeah, you have I wrote a prompt and it's giving me code now. So again, as I said, it is AI generated. So you definitely want to verify, especially if you're trying to put it into a production environment. But it's a cool little feature to sit and play around with, and especially if you want to learn how to do things, type it in and see what happens.
Right.
We've also got a contest page. So I'm going to just leave this. We've also got, we've got this MATLAB Shorts mini hack going on. You can essentially show us what you're doing. I'd recommend you go and take a look. The one that I'm really excited about talking about today is the Sumilink Student Challenge. So the Sumilink Student Challenge is essentially a way for, if you're a student and you've done something cool with Sumilink, I don't know, you've flown an airplane, you've landed a satellite, I don't know, be as creative as you can, right? But if you've done something cool, we'd like to hear about it. So send us a video that's 3 to 5 minutes long, definitely shorter than 6 minutes. And we'll have some of our engineers judge all these submissions. And you can win some cash money, up to $1,000 for the person that comes in first. Here are some of the dates that are important for you. The submission deadline is we're about 2 months away from the submission deadline. So if you've done something cool in Sumilink, you still got 2 months to try something cool in Sumilink.
Right.
Please send that over our way. You can find the Sumilink Student Challenge. We'll pop in a link in the chat so you can get to that. But yeah, upload your video to YouTube or Bilibili if you're in China, and send us the video, and we should be, we'll hopefully you win something. But we do this every year, and the Sumilink Student Challenge 2024 is live. All right, I know we're almost at the top of the hour, so let me go and look at the chat real quick to see if there are any questions available. Right. And
yeah, so
we'll probably hang around for five minutes or so. So if you've got any more questions, it's your last chance, and we'll try and answer as many as we can.
Right, so we've got another question. They're asking about controlling electric motors combined with a CVT, so a continuously variable transmission, to control using the fuzzy method. I assume they mean fuzzy logic.
Yeah.
So they're trying to use Simscape and Simulink to figure out the efficiency of that and compare it to a conventional motor. I know actually on the file exchange, we've just put out a model that involves a CVT. It doesn't involve fuzzy logic as far as I know, but it covers heavy machinery. So I believe it is there's a model of both a bucket and a bucket loader and a backhoe.
Yeah, I can look that up.
Yeah, and I believe our wonderful math worker Steve Miller spearheaded those with some help from some other people within the company. All right. We have another question. Somebody is wondering about blocks. There's so many of them. How are they supposed to know what they mean in the beginning? How are they supposed to be able to parse through all of this?
Ooh. Can you repeat that question? I don't think I caught that.
So they're wondering about blocks. I assume they mean within Simulink. There's so many of them. When they're getting started, how are they supposed to know what they mean, and how are they supposed to decide which blocks to use?
Yes, that is very interesting. That's a good question. I do think there is a learning curve with Simulink, right? Like you have to you have to kind of figure out what's possible and what's not. But I feel like there's a learning curve with everything. Like the first time you learn MATLAB, you didn't know all the functions in there, but you have the documentation. So go ahead, check that out. And I think I think what I use, Eric, you showed the sort of block finder view in Similink. When I first started using Similink, I always preferred going to the library browser. So if within Similink, if you look at the tool strip, you'll see something called the library browser. You click on that. It kind of gives you a more, it kind of breaks down the blocks for you in terms of, the aerospace toolbox has so-and-so blocks. Or within the aerospace toolbox, I've got atmosphere models or guidance, So I actually, if I have MATLAB open, let me show you what I mean by that real quick.
Right.
Yeah, but yeah, it's essentially you're able to visually sort of see, okay, this block kind of fits in with the aerospace tool, or at least I know what's available. So I used to, when I was first starting out, I definitely preferred going to the library browser to find these things. But yeah, I'd say check the documentation. That's the way to go.
Right, yeah, definitely look through the examples in the documentation too, because if you have something specific in mind that you want to do and you don't know how to do it, we probably have an example that covers something at least related to that. Yep. That was how I learned a lot about how to use Simulink, was looking through our examples and figuring out which blocks are used where. And I still even do this sometimes today, just going directly into the product and finding those examples.
Yeah. I'm just gonna, once this opens up real quick, I'll show you where you can find the library browser. But yeah, let's take a look at another question.
All right. So it looks like we've got only one more question left so far. But if you have more questions, definitely send them in. How about explainability with deep learning models? How do we provide explainability?
Ooh,
that's a tough one.
It's a tough one. Well, I'm not really an expert on deep learning, but I know that we have a number of tools where you can essentially expose layers of the model, right? So if you've got a deep learning model with a number of layers, you could kind of expose the model at different stages to see what the outputs are. But I do feel like explainability of AI models is perhaps out of the scope of the MATLAB toolchain. I think that's more of a, it goes a lot more into how the model's actually built, and so on and so forth. So maybe I can look up some resources for that.
Yeah, but I think Heather may be working on that. Your good friend Heather Gore.
Oh my, yeah, we can definitely follow up with that question. I'm not the best expert of this. But anyway, so as I said, this is the library browser, and we've got another question that says, "What's your favorite Simulink block?" Ooh, you take first pick.
I think my favorite, well, my most used is obviously the gain block because it is everywhere. My favorite is probably the 6DOF block within the aerospace block set.
Ooh, that's a good one.
It is fantastic for being able to simplify modeling really complex systems. Just being able to provide a force and moment at any given time and have it spit out all of the necessary information about how to even about how to convert between different frames is so valuable.
For me personally, I think any of the device driver blocks from any of the support any of the hardware support packages, because I am not a programmer. I'm a mechanical engineer that needs to program hardware every now and then, and I do not understand C++. I do not understand device driver, so I'm glad someone else does it for me, and I can just copy a block.
Somebody is wondering about getting their MathWorks account created and they weren't sent a code. So I wonder if maybe we can follow up afterwards with them specifically and see if we can figure that out.
Yeah, maybe if you can, I don't know what's the best way to reach out to us, but yeah, I think you can contact our customer support team, and they might be able to help you with that.
Yeah.
But
would you like to show about the library browser?
Yeah, so as I was saying, library browser, you can click through this. It sort of breaks it down by type, and then you have the blocks here, right? So it's a little easier to find it as opposed to typing the name in, and you have to actually know the name to be able to find it like that. So yeah. But yeah, I think that's all that we have time for today. Thank you so much for hanging out with us for the last hour or so, and smash that like button, hit the subscribe button, do all the good things.
Absolutely.
If you have more questions, if you're watching the stream after the fact, you have more questions, drop them down in the chat. We'll try and answer them in the next few weeks. But yeah, thank you for hanging out with us, and we hope to see you again.